Thank you all for joining us today for the now online Future of Blockchain 2 finale. We did have a big event planned in London, but as with many things in the world at the moment, that was curtailed. So we are happily online. So today we have two things happening. One is the pitch competition for the winner, the winning prize of £10,000. We have 12 fantastic projects competing today for that prize. And second of all, we have the general prize giving for the competition. I think we have over 45 prizes to give out today across the many fantastic challenges that our great partners have put on throughout the competition, and we're delighted to give those out. So to give you kind of more information about Future Blockchain, it's a very simple concept. It's a competition that's lasted 3 months, aimed at university students, researchers, and alumni to either answer a partner challenge that's been set or build whatever they like. And the concept of having 3 months is intended so that we get, compared to maybe a typical hackathon, a more deeper project kind of built, a bigger, better project built, and that kind of the students and our participants can really sink their teeth deep into kind of blockchain and the technologies involved. So we've run it, as I say, since October, when we had the first launch events in Oxford, Cambridge, London, and Berlin. It's been a long old road, a little bit extended by coronavirus and affected towards the end. But we are here now, and at online finale day. I would be remiss not to mention our fantastic partners we've had this year, offering challenges on the gold side, Algorand on Tezos, on the silver side, Graph, Near, Oasis, SAP, Zilliqa, and on the bronze side, Catalyst, ADEX, Arweave, and Witnet. And we thank them very much for not only their creative challenges and their fantastic and generous prizes, but their fantastic support to all the participants and helping their kind of journey in the competition. So thank you all very much. As I say, I was doing the totting up last night and quite shocked by how much money we have kind of organised to be given away today across the kind of 11 challenge platform partners and their many challenges. There are 45 prizes being given away today, over 45, and over 100k will be distributed by the end of this call. We also had some fantastic corporate partners whose purpose was to kind of add value, not by offering challenges, but by kind of more indirectly with their support, both technical and with connections for the individual teams taking part in the competition. So we thank very much the Ethereum Foundation, WeWork Labs, Binance, Huobi, Hyperledger, and Consensus for all their ongoing support. So very quickly, I want to get to the pictures as quickly as possible. A few statistics. So we had 560 participants across our universities this year. Those were Oxford, Cambridge, 4 in London and Berlin. Well, those are our core ones. We then had kind of inbound interest from many universities, like the University of Rome, University of Stirling, University of Waterloo, University of Cape Town, many that we didn't directly kind of market towards, but wanted to join the competition. That 560 participant figure is 20% up on last year. We had 140 teams start, 72 teams finish. On average, a team kind of had 3 or 4 people involved. About 40% of those are at least master's level, and of our finalists, half have at least 1 PhD, and we have 3 professor-led teams being represented in the final today. And the kind of stat from last year that I was picking out is that 10% of the finishers, which was about 60 projects, raised investment after the competition, and I very much expect that number to be higher through for the participants this year, who've been an outstanding quality overall. As I say, these are the universities we worked with and have helped us, and more importantly, I've lost the slide. I had a slide that was about societies. We very much thank the societies and student societies and clubs who have helped us run the competition on the ground on a week-by-week basis. The blockchain societies, the entrepreneurship societies, computing societies. I know most of them are kind of on the call today. So thank you very much for all your help. And we couldn't have done this competition without you. Very good. So on to the substantive bits. We have pitches now going on that are going to happen. Our 12 fantastic finalists who we've chosen will be pitching. We'll then do the challenge prize giving and have all the brilliant challenge partners present their prizes. And while during that time, our brilliant judging panel, who I'll talk about in a second, will deliberate, and we will finish this call with the prize giving for the best project in the whole competition, the 10K prize winner. So we have an amazing array of judges today who are going to help to well allocate the 10K top prize. First of all, Curtis Spencer, who is a general partner at Electric Capital, Kartik Talwar at A Capital, who's also a general partner, Minteo from Consensus Labs, Pamir from Libertus, and Paddy from Any Sender, which is his company, and he also has an academic background and was a judge last year, so we have a little bit of continuity there. So thank you to our judges for being part of this. We look forward to your judgments, and I think now is the perfect time to get started. So the way this will work is each of the finalists gets around 3 to 4 minutes to pitch. They will be sharing their screens. After that, they will have 2 minutes for questions. So our judges, we ask, this should be around 1 or 2 questions we have time for each participant. And furthermore, judges, you have a separate spreadsheet. Damir is going to be looking after you and making sure you have everything you need and kind of guiding the judging process. You have a separate spreadsheet to kind of put your comments and scoring in. So without further ado, Can Artistry, they're a team of Imperial undergraduates. They built a brilliant art provenance platform using Arweave. I will let Dan and the team say more now. So Dan, if you want to share your screen, we'll start the timer going and we'll take it from there.
Awesome. What makes this a €1 million piece of art and the other worthless? It's not the painting itself. It's authentic provenance, the history of a piece, the trail of ownership that means you can prove authenticity. Before every sale, the provenance of a piece needs to be checked over by every potential buyer, costing over €250 each time. Why? Because there's no one trusted central entity. There's nothing else like artistry. It's the first to integrate artist resale right, a legally required royalty throughout the EU, to a decentralized registry backed by Arweave, all automated with smart contracts in a trust-free way. We turn a process that galleries told us feels like a VAT return you have to do 4 times into something that provides value. We've shown artistry to some of the biggest players in the art market, people like the Design and Artist Copyright Society that administered over £10 million in royalties each year. Their feedback? They want to use it now. And we've got the technical chops to back it up. In the team, we've worked on research papers on smart contract programming languages, have over 20 years collective experience, and are all computer scientists at Imperial College London, where our white paper got reviewed by leading experts in this sphere, such as the Centre for Cryptocurrency. Let's show you the process on our serverless app deployed on Arweave. Nicola Theakston, one of the UK's foremost sculptors, has been excited about artistry, and we're going to register this gorilla on the platform. We fill in the necessary details about the piece, all while ensuring you don't repeat data. So you do this once, and it's saved on Arweave's permaweb forever, unlike the current solution. What happens on a resale? Well, let's say our friends at Flowers Gallery wanted to buy this piece from me. Normally, this would mean you'd have to organise an appraisal, fill in KYC forms, and then file a 4-page form for the royalty, organise to pay the royalty. It's a process measured in days. On artistry, it's already been done. But what about this royalty payment? Well, through our work on cryptocurrencies, you can pay with Euro stablecoins and prove you've paid it, and also ensure that the royalties will go directly to Nicola immediately. As for legal compliance and ability to audit, the governing societies can see the royalties are being paid and deal with offenders by freezing the provenance and associated value. This is just the tip of the iceberg. We have so many other features that the art market has told us it wants. Super detailed provenance, the ability to enlist someone to sell a piece on your behalf, registration of approved artists to act with more autonomy, and even integration with digital auction houses. We are artistry, and this is what we can deliver. Tamper-evident and tamper-resistant proof of provenance, effortless legal compliance, and artists will get all the royalties they are due. Thank you. Do you have any questions?
Awesome, thank you, Dan. So judges, handing over to you, do any of you have any questions for Dan? I realise that doing this online, we have a little bit of a coordination problem, but any brave judge who wants to ask the first question?
Well, maybe I'll jump in, Pamir here. Just
Awesome.
love to get your thoughts on go-to-market for this. So what do you need to do to get this to be used by a lot of folks?
Sure. So we've actually been talking to Dax recently about taking it to market and working on stuff like that. To us, what we need to do is go more on the privacy side. So some artists have concerns about stuff like the high resolution images of their stuff being displayed. It's a solved problem. It's not something which we think is very difficult to do above and beyond what we've done already. It's just we only had 3 months, so we ran out of time, but we do think it's an easy, quick step to go forwards from there on.
Awesome. Any other judge questions or follow up from Pamir?
No.
Hi. This is Curtis. I had a question on sort of when you do take it to market, do you target smaller galleries or do you target auction houses like a Christie's or Sotheby's?
Interesting you mentioned Sotheby's and Christie's, because they actually they published a paper recently about working with the blockchain. And they would be the kind of people we'd want to market it to, because they have the most to gain by demonstrating how good they are about complying. They do a lot of stuff at the moment about showing that they're really compliant, they're giving money back to artists and this kind of thing. So those would be the kind of entities we'd go for. And also they've got the money to invest in this kind of stuff beyond what small galleries go for.
Awesome. We have time for, I think, one more question. Any more judge questions?
That's a good question. So this is Patrick. So my girlfriend's an artist, she's a painter. And one of the issues she told me about online art is that people who want to buy art want to see the real thing, to see, what is the quality of this art. So how do you try to recreate that experience in a virtual manner? And the second one is, where's the art stored? So when you actually do that transfer, do I actually deliver you the art, or do you just own the right to it, but I still hold it myself?
Okay. So to answer your second question first about where's the art stored, we kind of separate this out into two different things. You have the ERC-721 token that represents the art within the smart contract world. And then you have the metadata, which is on Arweave. And then there's a link together with just a hash. So that's, in terms of the data stored, that's where that goes. As to the first question about physical experience and how to replicate that.
The art itself, like the actual art itself, is it really digital art or is it physical paintings?
It's meant for physical art. So the linking between the physical art and the digital token is a problem which some people have been looking to with like dust. So you can have quantum dust, which is uniquely connects the two. But what we think is more important is because the value is so tied up in this provenance trail, like the piece we showed at the beginning, one of them used to be sold for a lot of money, and then they discovered that, oh wait, the provenance is fake, and now it's worthless. And it's that kind of thing. This is the proof of that. And it's like losing your certificates. If you lose your certificates, that piece of art is worth nothing now. And it's that kind of, that's why we see that people are going to keep these tokens linked with the physical art. How you can replicate the experience, that's going to be pretty tricky. I think it's something which is added on top of going into galleries. We wouldn't say it replaces that experience. I think it's just an add-on.
Okay, I think we'll end questions there. If any of the judges have additional questions they feel like weren't answered, I realize it's only a substitute. If you do want to message Dan and the team kind of privately on Zoom, that's also completely fine. But in the interest of time, we will move on. Share my screen again. So we are now going to, that should work nicely, welcome Team BaseBlock to the Zoom center stage. They are a team of KCL students from the KCL Blockchain Society, in fact, who have built a crowdfunding platform using Zilliqa. So handing over to Eduardo and the team.
Hello, everyone. Welcome to our BaseBlock pitch. BaseBlock is a prototype of a reimagined crowdfunding platform on Zilliqa using the XSGD stablecoin. So what are the first words that come to your mind when thinking about crowdfunded projects? Well, for most of the people we interviewed, these are the main concerns: fear of losing money and fear of receiving a product that is different from the one advertised. And those concerns are not without grounds. The problem right now is that there is very little in place to prevent the projects that receive funding from misusing the money without delivering. And many are simply scams from the beginning. We have built a backer-first system for raising and distributing funds to projects that backers can actually trust. The community will be in total control of the funds and constantly keep the project in check for actual progress and the meeting of the established deadlines. This is a brief demo of how the platform works. So the startup provides detailed information about the project, which backers can carefully review. It then has to define the steps to the completion of the project with their associated fundraising targets. These targets are met and verified by the community on an ongoing basis. If the project were to stop showing signs of progress, based on a predefined majority, backers could vote the project to end. In that case, the project would get a second chance to provide further proof of progress, and in case of repeated failure, the backers would recover all the remaining funds. This mechanism essentially works as a deterrent against fraudulent projects and gives control to the backers. We believe BaseBlock's biggest contribution to the crowdfunding market will be increasing the delivery rate of projects and attracting risk-averse backers to the platform, driving more funds to the whole crowdfunding landscape. However, a major problem with holding cryptocurrencies is their inherent price volatility, which would make storing funds for a long-term project unfeasible. And in fact, this is why we are working with Xverse to integrate their Singapore dollar-backed XSGD stablecoin in our platform. After that, another challenge will be handling the conversion from fiat to cryptocurrency on behalf of our users. This, we think, is crucial for the large-scale success of such a platform. The team that put this together is composed of multiple walks of life within the KCO Blockchain Society. We are 2 undergraduate and 1 graduate students of computer science and 2 students of law. This is BaseBlock. Thank you.
Awesome. Judges, do you have any questions about BaseBlock?
I have one. It seems like the critical differentiator from something like a Kickstarter here is like the slow playing of capital from the backers based on the milestones, which seems really cool. How do you prevent like an impasse with the backer governance? Like, say 50% of the backers are like, hey, these guys aren't hitting the milestones, so let's just cut off funding. How do you solve that?
So first of all, the majority is predetermined by the project, and while we don't enforce it, we would recommend the project owners to set something like a 90% majority or an 80% majority of backers voting negatively. Also, it works on a negative vote basis. So the backers can, by default, the backers will release the money. What they can do is they can vote to stop the money, and at that point, you would need more than 80% of the backers to actually actively vote for the halting of the project. So you would obviously not have a simple majority, but a much higher majority. And the backers could obviously choose also depending on that. For example, a 99% majority project would never be picked by backers probably. And also the voting is based on the funding. So if you were to, you would essentially to overthrow a project, you would have to fund the project yourself, or fund, the majority of the project yourself.
Good. Next question from any judges who might have one.
I have a quick one. So with regards to platform, how do you intend on getting liquidity on the platform? And do you have an idea as to who your target backer or funder will be for these projects?
What do you mean by getting liquidity? Do you mean for the exchange part?
Well, mainly getting, getting funders interested in backing projects on the platform.
Oh, okay. Well, our target in the beginning is probably the project that we think need this the most are hardware-based projects, because they're usually the ones that would that fail the most often and are the most expensive. So our strategy would be to partner with some projects and help them basically raise with a couple of example projects, and then try to build a user base from this first pilot project. We were also thinking about expanding in it could also be applied to software projects. That's also a fitting niche.
Awesome. I think on that note, we should move on. Eduardo, thank you very much for your presentation. And now, if I can get screen working, yes, I can. We will be moving on to team Chain of Insight. They have built zero-knowledge encryption, Oracle, and DApp on Tezos. And Drew and the team are very excited to tell you more. So Drew, over to you when you're ready.
Okay, Hello, everyone. Just setting up here. Okay, we are the Chain of Insight team presenting our project, Pop Machine Glow. So we're here to tell you about how we built a framework for producing lightweight zero-knowledge proofs on the Tezos blockchain. So what we're talking about here, of course, is blockchain secret sharing schemes. You've already heard about other secret sharing protocols for blockchain like Enigma and Chainlink, which are using Intel SGX secure hardware as a layer 2 network. So of course, these solutions do require additional infrastructure. And you've also heard about other zero-knowledge cryptography strategies like the infamous ZK snarks. Well, unlike ZK snarks, our framework is capable only of producing integer comparisons. So that means it's good for verifying information like times, dates, money, vector points, you get it. However, we can also produce a limited type of general knowledge proof if we use a trusted third-party data provider like you see happening in Chainlink's protocol. And with this type of proof, we can verify self-sovereign identity. Of course, that's good for things like controlling purchasing of restricted goods like tobacco, gambling, alcohol, etc. It's also good for performing KYC for things like exchanges. But of course, the big limitation when we're talking about ZK snarks is that they require such high amounts of computational resources in order to produce knowledge commitments. It's really just infeasible right now for ZK snarks to generate proofs from a mobile device or even from a reasonably powered laptop. So to use zero-knowledge proofs in a common everyday scenario on typical hardware, we really need something better. So that's where Pop Machine Glow comes into the rescue. So we're just going to hop right into a demo right here. So we call our knowledge commitments puzzles, and we provide proof of puzzle. That's Pop Machine Glow, POP. So you can see with this particular knowledge commitment, it has 10 rewards available. One of them was already claimed by myself, and we have the public proof. Notice that the public proof begins with F6 to F3. That's going to become important to remember that seconds from now, because we're going to go and produce a proof chain for this. So we do this by having the raw secret, which we can verify locally. Once we've verified it locally in the dApp, we can view the proof chain. So you see we start out at the top with the raw secret message, and we end up at the bottom with the public proof. You see that once again, it begins with F6 to F3. So that is the public proof that everyone can see. And then in between that, you have all these derivative proofs, which are incremental rounds of hashing. So if we take one of these derivative proofs, let's use this one at depth 4. We copy this proof. We see that it begins with 4CCE8. And we can go into the verifier. Let's just make sure we have proof 4. So we're going to need depth 4. And then make sure that I copy this correctly. And then we give our proof. We see that it's 4CCE8. We run the prover, and it verifies successfully. Of course, if we change the encryption depth, it's going to fail. If we change it back, of course, we'll have a successful verification. Also, if we change a character in the string, of course, it's going to fail. And if we change it back, we have a successful verification one more time. Just bringing up the slides again, bear with me. Here we go. So that is the story of how it's now possible to generate and prove a wide variety of zero-knowledge proofs, even from a mobile device. Of course, I invite you to go try this out yourself right now. There is a QR code which will bring you to this public knowledge puzzle. And the password for it is Future of Blockchain 2. So feel free to try that on your mobile device or your laptop or whatever. And if you have any questions, we're ready to engage with them right now if you've got questions for us.
Awesome. Well, let's move straight into questions. So judges, do you have any questions for Drew?
Hey, this is Kartik. This is really cool. I just have a question around just generally, what are the limitations of the types of proofs you can generate with just integer comparisons? Like I know you kind of talked about verifying third-party data, but is that more on being able to just prove that the data exists, or like actually being able to do something with that information? I didn't understand that.
Okay, yeah, I understand, because like we have a lot of knowledge to give off in a really short time frame. So maybe the easiest way to think about it is if you see the hash chains, right?
Yep.
What we're talking about is leaking out of the secret, right?
Yep.
So at depth 0, we have the raw secret, and at the final depth, we have the public version of the proof, right? And then in between, we have stuff that we know can't leak. So what we are storing is encrypted depths. How do we verify the source, right? Like, how do we verify that this, like, say I have a question that I'm asking, and I say this question is like the meaning of life, right? Well, how do you know 1, 2, 3 is the meaning of life? You're trusting me. You're trusting the data provider, right? So if we think of something like purchasing cigarettes, where we have to prove our age, the normal way that we do this is providing a piece of identity, right? So I give you like a passport or a driver's license, or in Quebec, we have these SEQ cards, you have health cards. You need to prove that you own a physical piece of identity, right? So in order to do this, and not be, the idea here is to prove you are who you say you are, and you're as old as you say you are, without having to show your identification and actually like leak out private information about you. You know, like my passport says that I live in Montreal, but with a zero knowledge based proof system, with a third party provider, the third party provider, like say a government, provides the hash, right? So the government is providing this secret. So you're trusting the government is not lying that I'm that I'm actually such and such years old, right? Because when you're verifying it in zero knowledge, the point of sale vendor is never going to actually be able to know, because they're just going to be doing everything in zero knowledge. And
awesome. Drew, I'm gonna cut you off, because I know you could say very wise things in a long time.
Yeah,
so what I'll allow is one
I hope that was clear.
More question from either Kartik on a follow-up or another judge, if you have it.
I do have a follow-up question, but I'll let somebody else ask first. I just have a quick one.
I can ask. So I can also take Dust Network's question. So what proving system are you using under the hood while it proves Graph 16 and Plonk? And I guess this is very simply, are you just proving the pre-image of a hash? Or are you proving something more meaningful?
That is correct, yeah. So it is using hash chains and private integer comparisons on hash chains. So this is coming from a 2013 paper by Michael Wolfish and Sebastian Engels. If you go to our repository, you can read the full paper. There's also other academic data on it, but yes, it is pre-image of hashes. So you could say that it's a glorified version of hash lock transactions with derivative chain proofs.
And we will stop it there. So as with before, if judges / teams have any other things they want to add and ask, please do it in the kind of private chat. As for their repository, which I know that Drew mentioned there, judges, you should have in the spreadsheet all that information, but ping myself or Dammit if something looks like it's missing or unclear. Moving on to our next participant is Chiron Coin. It is a team of 6 led by Fenny, who is a PhD from Ecole Central and also a Cambridge MBA. They've built a marketplace for sharing trading algorithms built on Near Protocol. So Fenny, handing over to you.
Thank you, Anthony. I'm trying to share my screen.
Excellent, it's coming. Very good. When you're ready, Fanny.
Okay. Awesome. I'm Fanny, founder of Chiron Coin. My team is solving the Near Protocol challenge. Chiron Coin trading platform is a platform sharing algo trading analytics for retail investors using cryptocurrency tokens as share token. It will revolutionize the way retail investors make investing decisions. Why are we the perfect team to make it happen? I'm PhD in math. With 10 years mathematical modeling experience, I'm currently front office quant in a tier 1 investment bank. My team has diverse experience in banking, academics, marketing, legal, running companies, and 4 of us are Cambridge MBA. Why is the problem we're solving so important? To give you an example, the financial market recently is very volatile, hit by the coronavirus. While many retail investors were caught by making wrong decisions, some institutional ones managed to make profit, benefiting from the advanced analytics like AI-based algos. If these tools can help them catch opportunities, why can't we do it for retail investors? Our market study shows 300,000 premium users in UK market are keen to use algo analytics. However, current trading platforms are either not providing advanced analytics or too expensive. In our solution, algo token is defined as cryptocurrency token with algo as underlying. By buying algo token, the retail investors get access to the underlying advanced analytics. How can we cut price? Often, the professional traders have some algo with performance under the institutional standards, but interesting for retail investors, like 10% annual return. Our platform supports them to upload and share the algos by publishing algo tokens and make profit by charging users. Given these algos are unused asset, and when there are large amount of providers, the price will be reduced. Why blockchain? Thanks to it, an interesting market behavior emerges. As algo token value is associated with algo performance, by freely trading algo token, it provides exposure to the financial positions and it can be used as an instrument to speculate and hedge. And besides, we benefit from the blockchain features, for example, the enhanced security, boosts the liquidity of algo sharing. I will now show you, I will now show you how it works with a demo of our proof of concept prototype. 3 captures are set up in our platform using the Near wallet. Alan, as an algo developer, he uploads and shares his algo by publishing algo token. He makes profits by charging the users. Bob buys the algo token from Alan. He gets inexpensive access to the underlying algo analytics, and which will assist him investing in the stock market. Cassie is attracted by Alan's algo performance. She could either buy the token from Alan or Bob, and which gives her opportunities to speculate the algo token values. Financial markets today are very volatile, facing the risk of financial crisis, global economic recession. Timing has never been so crucial for us to bring current coin to our customers and give them competitive edge to trade in the market. As next step, if we win, the prize will be used to keep developing the application. And I'm very happy to talk more about it in the Q&A session. Thank you.
Awesome. Questions from judges?
I have a question. So, say in your example, you have Alan who ends up being an amazing algo developer.
Yeah.
What incentive does he have not to just go start his own fund or trade his own capital as opposed to sharing the algorithm out?
Yeah, so as I explained here, so how can we cut the price? And I said like professional traders, they have some algo with performance under the institutional standards. Like if it's not 20% or 15%, the fund will not be interested. But for retail investors, they will be interested of 10%. So it's like unused algo asset, not interested by hedge fund, but interesting for retail investors. And they are unused algo assets and can be used for retail investors and with a cheaper price.
Good. Any
Okay,
other?
so like a
Go on.
lower,
Yeah,
like a
proceed.
lower quality algorithm that, you know, a hedge fund could say, hey, this is kind of our consumer version, and we'll throw it out there for retail investors. Is that what you're getting at?
Sort of. I wouldn't call it lower quality. I would just say that it's like different features of algo, like maybe less certainty but less return. But different kind of product have different target market.
Awesome. I am conscious of time, so we will move straight on. Fenny, thank you very much. As ever, judges, if you want to ask additional questions, please feel free to message Fenny on Zoom chat. Moving straight on into Airbnb. This is from a professor from the University of Stirling and team, and they have built a decentralized property marketplace on Tezos. So Andrea, handing over to you.
Hello. Okay, so you should see my video, correct?
Correct, yes,
okay.
All good.
So, okay, this is a Airbnb for the Tezos Challenge #1. I'm Andrea Bracciali from Stirling, together with Daniel Brovi from Strathclyde and Siham, a visiting student from Morocco. And this is our paper that will be submitted for peer review about this experiment. So, you are set for your next holiday, but you find yourself in a highly centralized market. There are a few dominant positions, the usual suspects, and this makes the market unfair and inefficient for both the guests and the hosts. So there are high intermediation costs, there is a huge asymmetry of information, no real negotiation is possible, and all the trust is in dominant players. Let me give you a concrete example. Gaia is a guest, has booked with Herbert, and at a certain point she cancelled. Gaia is gold because it's very important for her, Airbnb. And Airbnb decided to refund her anyway. They're breaking the contract with Herbert. Airbnb can do this by finding Gemma, another customer for Herbert. But of course, Gemma would have gone with Henry, booking with Harry, which who has got a loss and is not even aware, has no control of what has happened. Everything is behind the scenes. So the solution is a novel and complex decentralized application that allows untrusted parties, G and H, to trade together. The trust is enforced by, of course, the decentralized consensus and suitable financial incentives via smart contract implemented on the Tezos blockchain. This is grounded on strong theoretical results. So technically it's a double escrow. So the participants have to put some value in the game, the famous skin in the game. And game theory tells us why it's counterproductive to misbehave. And we can quantitatively characterize the risk, the optimal values, by using formal methods and particular stochastic model checking. In the end, we have an efficient and fair market with risk protection, of course, up to given an assumption. This is the general framework. So G&H decides some rental agreement. They can use a library of established correct agreement, and then this is formalized. We have used SmartPy in a high-level language to program a smart contract. This is formalized in a smart contract that runs on the Tezos network, and we have some Conseil.js interfaces for the participants and for some Internet of Things that you use as an oracle to inject information about what's going on. So let me give you a brief example of how this works. So this is an interface for the host. This is an interface for the guest, and is doing a deposit. Of course, this takes a lot of time because it's interacting with the network. So let's go to the simulator, and let me show you a possible transaction. So the contract is initialized. These are all transactions that are sent to the smart contract. This is quite interesting. It's brown because actually the guest is trying to cheat. So he's trying to cancel and get refunded before putting the deposit in. And this is not allowed. We have used type checking. We have used dynamic checking of who is doing what and which are the permissions and so on and so forth. So the transaction goes on, the guest can complain because this has been agreed in the agreement that has been encoded in the contract. And in the end, it's quite important to see this last transaction, which is the optimal final point where everybody wants to arrive, and the skin in the game is redistributed in a fair way according to what has gone on. And this is the real incentive to bring the contract to a successful completion. And this is basically the quick summary I wanted to give you, and I leave you with our contacts if you want to get in touch or ask any question.
Awesome. Judges, do we have any questions? Judges, any judge questions?
Everything clear?
I think that means everything's clear. In that case, we will move straight on. Andrea?
I can ask one question if you want.
Yeah, go on, Paddy.
Yeah, so with this sort of the Airbnb and I guess basically these decentralized applications, how do you see making money from it? So what would be like your revenue model? How would you, if you were going to deploy this tomorrow?
Okay, so this is of course a very strong point, because in the decentralization and disintermediation of markets, you are losing the middle in demand who was making money. We are exploring possible additions that are, for instance, the possibility of creating a sort of community fund, essentially for risk management. This should be related to, I think, something like long-term reputation that gives you increased revenue. And so there is a surplus. The surplus that is usually taken by the middlemen should be redistributed partially to the community and partially to whoever developed the system, in this case ourselves. And if you scale this to a large number of customers, it's enough to take a small amount of money, and you can make a huge income. And quite surprisingly, I didn't realize this, but I think that the first customer will be the host, because the host so the contract conditions, the booking, Airbnb, and so forth, are able to impose to the host. The example I showed very briefly is just an example, are quite tough against the host. They really have no control. They don't know what's going on behind the scenes at all.
Very good. Very
okay.
good. We're going to move on. I'm conscious of time. Andrea, thank you very much. From one Andrea to another Andrea from the University of Rome. He has built a platform, or rather a decentralized Robinson list on Algorand. So handing over to you, Andrea.
Yeah. Okay. So good afternoon. My name is Andrea Vitoletti. I'm going to present the decentralized Robinson list, the umbrella to protect your privacy without intermediaries. Most likely you received a spam call in the last days. There was an increase in spam calls of 18% last year, and 50% of respondents to a recent survey by Google declared that they receive at least one spam call per day. We call this phenomena marketing storm. The current way to protect yourself from the marketing storm is revoking consent. Robinson list is a national centralized archive of consent where user can declare whether he or she wishes to opt out from the list of citizens that can be contacted. Robinson list exists in many countries. In Italy, we have the Registro Pubblico delle Opposizioni, managed by Fondazione Ugo Bordoni since 2010. Fondazione Ugo Bordoni is one of the partners of the project. Today, the Registro Pubblico delle Opposizioni manages roughly 1.5 million of records, but is expected to manage about 100 million of records by 2021. Okay, so what is our solution? Our solution is a decentralized, hopefully transnational Robinson list on blockchain. And specifically, we have realized a prototype of the decentralized Robinson list on Algorand. Why decentralized? Why on a blockchain? because our main goal is to empower citizens to autonomously manage their consent without the need of intermediaries, as expected in the current centralized approach. The implementation on the blockchain allows us to foresee a cross-border deployment, which is the natural and desirable evolution of our project, and can result in a cost-effective transnational deployment. Let's have a look to a quick demo. So on the left side, you see the Robinson list in which you have users with their status, whether they are opt-in or opt-out. On the right side, you see the console of the user. In this particular case is a user 1. The current status of user 1 is opt-in, as you can see here, and as you can see in the Robinson list. So you simply push on the opt-out. Okay, and that's it. So in terms of technical ingredients here, we are TEAL smart contract, assets, and atomic transfer. Now the transaction is written into the chain, as you can see here. And if you refresh the Robinson list, now user 1 is opt-out as expected. Okay, let's move on. Okay, the team. Our team is made by members of Fondazione Ugo Bordoni, that is currently managing the Italian Robinson list and does has all the necessary in-field experience to port the current centralized solution into a decentralized context, and by researchers from the University of Rome, both Rome La Sapienza and Roma 3, which are experts on blockchain technologies. Concluding, we are committed to evaluate, with the support of Italian institutions, the porting of the Robinson list into a decentralized architecture. That's it for the moment, and open to questions.
Thank you, Andrea. Note for all kind of finalists, if we can keep answers nice and short, just so we can get through more questions, that'd be awesome. So judges, do you have any questions?
I have a quick, sorry, go ahead, whoever that was.
You go ahead. Yeah,
Thanks. I just had a quick question. So just to clarify, is the list itself the data being stored on the blockchain here, or are you just storing that this person's intent to opt out is the verification that I'm going to put on Algorand or any blockchain?
So basically, just to go a bit more into details, each user has a token as an asset, actually. It can be either opt-in or opt-out. So the purpose of the smart contract is basically to exchange an opt-in token with an opt-out one. And in particular, what you do, you use an atomic transfer in order to be sure that only if you give back an opt-out token, you get an opt-in, and vice versa. That's the whole story.
Got it.
Very nice. Next question.
Yeah, have you thought about people maliciously using this list? Like anecdotally, I know like when I put my phone number in the do not call registry, I actually got like way more spam calls. So it's almost like a whitelist of now, I have a contactable phone number. Do you worry about that?
There are actually a number of issues, right? Because as an example, you have to provide a privacy preserving solution, but at the same time, basically you have to be sure of the identity. Indeed, the identity on the chain and some kind of proof of possession of the mobile phone is one of the issues that we are going to handle in the near future. But you're right. I mean, this is a proof of concept. We have still a lot of work to do. But what is interesting to me is that now we can actually compare the performance of a centralized solution with a decentralized one. As I told you at the beginning, we have a significant number of users that can in principle use this kind of solution, and only in Italy. So that's one issue. And again, we have a lot of work to do, but I do believe we are in the good path.
Awesome, Andrea, thank you very much. We are moving on now to Team Deepverse, a team of Cambridge PhDs who have built a model platform for training models collaboratively on Tezos and Arweave. Handing over to Fred to tell you more. Fred, are you there? Fred, are you there? Fred? Well, Fred seems to have an issue. So what we're going to do in that case is rearrange the order slightly, and we will go straight to Team Digi Options while Fred sorts his issues out. who are a team of two who have built an online betting platform. So Holger, if you're ready, we'll go straight into you.
Okay, thank you, Anthony. I'm ready, and welcome everybody to Digi Options. Digi Options is an online betting platform. And if you like betting, you will love Digi Options. There are two things special with Digi Options. First, we are user-driven. That is, it's the users who define the events to bet on. They open up the markets. They could open up betting markets on stocks, sport, politics, on anything you can imagine. Second, we are totally decentralized, meaning we are transparent and we are secure. You may have heard of all the centralized exchanges being hacked and millions of dollars lost. So this is what a betting market looks like at Digi Options. For example, you could take a bet on the Bitcoin cryptocurrency, and you could expect it to lie within this blue range by the end of the month. So we will have a live demo in a second. How to bet on Digi Options? That's really simple. All you need is an Ether wallet. Then you select the betting market and deposit some Ether on it. You take a bet, of course. And when finally the market is settled, you will automatically get your winnings. And there's no registration at all. So it's really simple. Now what we built is a decentralized app running on Ethereum. It's a peer-to-peer protocol with a graphical user interface for the web and an automatic trader in order to fill up the order book. And of course, we need some provable signatures. It's running live now on Ethereum. Indeed, we went live in mid-March, which was the final submission date of Future of Blockchain competition. We are a small but very experienced team. My brother Ulf, he's a tech guy. He's from Technical University Berlin, an engineer. He's an Ethereum expert and has experience in market making. Myself, I am an economist and statistician, a fintech founder, and I worked as an insurance manager. So now let's have a look on Digi Options. Currently, we have 3 cryptocurrency betting markets for Bitcoin, Ether, and Ripple. And I will choose the Bitcoin market. You see it's moving in the highest range and it's going sideways today. Now I expect to drop it down on this range, which is a quite sharp drop down to the end of the month. I will accept these prices and just buy a tiny little bit, 0.01, and I click now. So I have to confirm it on MetaMask. I will do that. And as you can see, the transaction is now sent on the blockchain. And indeed, this is real betting and real money. This could take up to 30 seconds. Once the transaction is finished, you can see it here on the transaction list. So it's very easy and it should be fun. Enjoy Digi Options, the user-driven option markets. Thank you.
Thank you very, very much, Holger. Questions from the judges?
So how do you think about going to market with Digi Options? I guess right now it feels like Digi Options sits somewhere between centralized markets where you can buy and sell options and some of the decentralized markets that are in existence. But who do you think is going to be using Digi Options and why?
Yeah. So we will offer markets that you won't find anywhere else. Of course, you could buy cryptocurrencies. That is a spot market, but you won't find much derivatives markets. And taking bets is a financial derivative, and it should be a market 10 or 100 times larger than the cryptocurrency spot market. So we are quite confident we will technically find traders wanting to hedge or to take risky bets on cryptocurrencies. And finally, we will open up the universe for sports and politics and other events. And people like you and me could place a bet there, which will create a very huge universe. And we are happy to have some test users, and they proposed to create some very special markets. So it could be interesting in future.
Great. We're going to move on now in the interest of time. So we will now move on to Team Hyperaware, if my presentation will come back. Team Hyperaware, who are a team from London Blockchain Labs, which is a composite group of Imperial, UCL and LSE students. They've used Arweave and also representing SAP today. I will hand over to John to tell us more. Over to you, John.
Anthony, I'm afraid I believe there's just a technical glitch. I'm going to have to bump about one.
All good.
I'm sorry.
All good.
Yeah.
All good.
Sorry about that.
So calling Q vote. This is always going to happen despite our many rehearsals. Calling Q vote. Q vote. Are you ready to go, Matish?
Yes, I think so. We should be ready. Good. As long as Eduardo shares the presentation.
Eduardo, you ready? Eduardo? Eduardo is ready and sharing. Very good. Okay, so Qvotes are a team also from KCL Blockchain, and they have built a voting platform on Tezos. So Matish, over to you.
Okay, so I think I'm still waiting for Eduardo to present. Yep. Yes, and now we're good to go. Okay, so hello everyone, and welcome to our Qvote pitch. So what is Qvote? Qvote is a website which you can check out at qvote.uk. It is able to deploy, interact, and manage the full lifecycle of an election powered by smart contracts. The website is currently able to dialogue with Tezos, whose challenge we're competing in, Ethereum, and soon Thundercore. Current voting systems force all the voters to express their views with the same impact for all issues, regardless of how important they are to them as individuals. Qvote uses a voting rule that is quadratic, meaning that it enables people to express a variable influence proportionally to how much they value a decision. Credits are used to purchase votes, but get quadratically more expensive. Our product, which stemmed out of necessity, was successfully used during KCL Blockchain's annual core circle elections earlier this year, handling over 60 voters and 20 candidates. Qvote leverages an easy-to-use user interface that reduces users' friction when interacting with the Tezos blockchain and intuitively guides them through the quadratic voting process. Your average user will be able to utilize the voting platform by simply using a supplied mnemonic as a one-time password to generate their transactions. Whereas thanks to the nature of blockchain, more concerned users have the ability to vote independently from our software and verify transactions themselves. Our voting solution uses Tezos to store votes, as it allows us to offer immutability, decentralization, and pseudo-anonymity to all of our voters. Our server simply acts as a gateway to help process transactions by the user, making for a seamless user experience. Due to that, we are able to minimize the trust structures usually present in government processes. Our business is to act as a software as a service, where we sell our domain extensions to clients, such as corporate boards, to allow them to create their own custom elections whenever they want through the content management system that we implemented. As well as continuing to test and advance our current implementation with our future clients, we plan to shift our development to the React Native and Google Firebase stack, thus allowing us to scale very easily due to the Google Firebase service and adapting our product to the most fitting ecosystem, that being mobile apps. We are a team of undergraduate computer science students from King's College London at the head of the KCL Blockchain Society, and this is Qvote.
Excellent. So questions for judges. Or judges, sorry, no, not questions for judges, judges questions.
You mentioned corporate boards being a target market. How are you thinking about privacy preservation there? Like, I imagine a lot of like corporate boards that are, you know, they want to keep the process confidential, especially if there's like a very contentious board vote.
Well, yes, that's one of our focuses where we use mnemonics as the basically your one-time permission to vote, and those mnemonics basically are assigned at some point to a person, and this fact. Sorry.
Can I jump in for a second?
Yes, of course.
Pretty much the idea is that we leverage different. Hi, I'm Fred. I'm from QVote as well, from KCL Blockchain, and we leverage different depths of security to make it work, and we try to tailor it for the use case. So first of all, we use security by obfuscation. So we only put out enough information for people to know what's going on. And on Ethereum, we have the option of running permissions networks. So we can shield the whole state of the network while still keeping a few decentralization guarantees, depending on how we set it up. And we also believe in a product-driven approach. So we tried to get an MVP out, and that's what we did, and we validated it with clients. And now as we extend it to other people, we want to roll out different characteristics for this product, like maybe a privacy feature, maybe zero-knowledge proofs. And we want to interact with the ecosystem and other projects that are currently doing that, but they're still in research phase. So what we're doing is we're getting users, then we're using their research.
Awesome. One more quick question.
I can ask one. So I guess there's one comment is I would never do security for obfuscation because that doesn't really work. I think what you guys should probably do is if you're going to run this as a service, when people come to you to register for the election, you can give out blinded tokens called a blind signature. So then basically if there's 20 people coming to get tokens, you can authenticate who they are, but you can't do a one-to-one matching of the server and the new token.
Yeah, I get what you mean, but what we do actually is we take the cost of generating new accounts and pre-funding them. So when we give out the mnemonics, they actually are brand new addresses for users to use.
Oh yeah, you can do that
with
by
disposable, and it gives pretty good privacy.
I mean, if you're just giving the token to them, there's no privacy from the server. So I would look at blind signatures.
Yeah.
Very good. We are going to move on there. So we'll now move on. We're going to try with hyper-aware again. John, calling John. Are you there, John?
Yes.
Excellent. Well, handing it to you. Take us away when you're ready.
All right. And you can see that?
Perfectly.
Great. Our world is more connected than ever. People, things, and vehicles move from place to place, carrying network devices with them. These devices capture, process, and store and share information about their surroundings and their users. We have developed the opportunity to coordinate on a scale never before possible. But this opportunity is being squandered. Device owners have little control over the data produced by their sensors. Firms aren't willing to share sensitive information, even if it could benefit others. Governments use dated ways to apply policies to vehicles and people in their jurisdictions. These inefficiencies cost companies time and money, and worse, they let bad actors break the law. HyperAware is a spatial governance protocol for connected devices designed for self-sovereign users. We designed HyperAware as an open protocol, making no assumptions about the users or use cases. We've built an alpha implementation on IoTeX, Ethereum, and Arweave. Let's see how commercial transport might work across the UK and EU. Points represent vehicles with embedded connected sensors. Polygons represent registered policy zones. This advanced button simulates stepping through time as vehicles move across the earth. First, authorities register their geographic zones to our zone registry on an Ethereum smart contract and the Arweave permaweb. HyperAware uses decentralized identifiers to ensure zone owners have complete control and sovereignty over their zone borders and policies. DID documents describing policies and spatial data are stored on the Arweave permaweb. Zone owners will have the option to make spatial and policy data private. When a logistics company purchases a new truck, They register their device on the hyper-aware device registry smart contract. Device owners also control their identities using a DID and store the DID document on Arweave. When they register, vehicle owners stake funds to the contract so they can automatically pay congestion charges when they travel through a policy zone. The protocol is compatible with legacy location tracking devices as well, so no new hardware needs to be installed for users to join. HyperAware is optimized to be used with trusted IoT devices, so vehicle owners can choose to keep location data private. It is digitally signed and encrypted on the device. And here you can see private vehicles that only are detected once they actually enter the zone. As connected vehicles travel, their positions are streamed into the HyperAware private location analytics engine, where we analyze location data and zone geometries inside a secure enclave. If a vehicle is detected inside a zone, that zone's policies are automatically enforced by invoking a smart contract. As I said, we designed HyperAware to be versatile. Beyond congestion zones, we could trace shipments of arms to make sure they aren't diverted and used by terrorist groups. We could track fishing vessels to make sure they have not caught their fish in protected waters. We could follow medicines and be certain they are being delivered to their intended patients in developing countries. We could prevent drones from flying into restricted airspace, causing air accidents or costly delays to travelers. We could track the movements of people infected with COVID-19, making sure they stay quarantined, all while still respecting the individual's right to choose privacy. On top of all this, we can let governments and other zone owners just decide the policies they want enforced in their zones, who gets notified when devices entered, what information gets shared, what insurance policies are put in effect, how border checks are automated, where tokens can be spent. HyperAware is a new way for us to govern ourselves and our devices, designed for users to be self-sovereign from the ground up.
Thank you, John. Judges, questions? Do any judges have any questions? Yeah, go, Paddy.
So you mentioned the use of SGX and trusted hardware, and you said that was for processing the data. So my understanding is that SGX won't, SGX has to trust the input of the data that is doing the processing on, junk in, junk out. So how do you make sure there's no junk going in? How do you get reliable GPS data?
This is a great question, and this is why we established a partnership at the beginning of this project with IoTex, which is building trusted IoT devices that have ARM Trust Zone enclaves installed on the device. So when the device takes a sensor reading, whether it's location sensors or temperature or environmental variables, the first thing that happens to that information is that it's passed into the enclave on the device and digitally signed and optionally encrypted. And that way, because of the way secure enclaves work and that they have a private key inside that is only accessible to the device, any attacker after that data has been signed can't replicate a valid digital signature. So that's one of the ways that that's one of the ways we're addressing that question. Another one is by kind of using multiple devices, and it's difficult to spoof multiple IoT devices that are taking sensor readings. So a more probabilistic approach.
Awesome. We're a little bit tight for time, John, so we're going to move on. Now I will welcome, if I have my slides ready, I do. Welcome team Reflexer. They is one-man team, Stefan, and he has built an unpegged stablecoin. So Stefan, when you're ready, please tell us more.
Hi everyone, I'm Stefan from Reflexer. My team and I are here to save Ethereum from the MakerDAO monopoly. You see, Maker and most crypto collateralized stablecoins are flawed. Just last month, we saw that DAI cannot adapt to severe market shocks. In fact, DAI has been trading above its $1 peg for weeks, and right now the Maker community cannot do anything to restore the peg, apart from pumping more collateral in the system and making the next crisis even bigger. Luckily, the solution to this problem is simple. The stablecoin system needs to support both positive and negative interest rates. We are building a system like this using two different components that help each other. The first component will create a collateralized coin that is not pegged to anything. The purpose of the non-pegged coin is to follow the price of its collateral in a dampened way. So for example, if we use Ether to create a non-pegged coin and then Ether drops by 50% in a day, the price of the non-pegged coin will slowly go down over many weeks or even months. The second component will create a pegged coin that is backed by the non-pegged one. The pegged coin will use a mechanism similar to negative interest rates in order to adapt to Black Thursday scenarios. We published our work, and it looks like the Ethereum community is hungry for a project like this. We received hundreds of likes on Medium and Twitter. We are one of the top most viewed topics on ETH Research, a website where the Ethereum community discusses technical proposals. And we have a growing list of more than 25 people who want to join the team. We plan to launch a simple website where anyone will be able to create both pegged and non-pegged stable assets. Depending on community demand, we might also create multiple systems, each one being backed by different collateral types. Right now, we have a smart contract proof of concept that has negative interest rates baked in. Governance has limited power over the system. We have an Oracle component that is harder to manipulate compared to the one used by Maker, and the system itself can set its own interest rates in response to market forces. As for our team, I've been studying stablecoins for 8 months since Binance awarded me a grant, and I recently partnered with Metacoin. Metacoin is an initiative on Ethereum to create governance-minimized alternative to DAI. They help me with community building and technical advice. That's it. Thank you.
Awesome. Judges, questions?
So I'm guilty of not having read the Medium post, but just wanted to understand how the intermediate coin functions. If you could shed some more light on that.
You mean the non-pegged one?
Yes.
It's actually the initial design for DAI, but they abandoned it. And last month they saw that it doesn't really work if it's just pegged. So we have a concept called the redemption price. In DAI, the redemption price is always 1 because it needs to be pegged. In the non-pegged asset, the redemption price always changes in order to incentivize CDP creators to create more or less coins. In the pegged one, we keep the redemption price fixed until Black Thursday comes, and then we depeg temporarily, and then we bring back redemption price to 1.
Awesome. Any other judge questions?
How do you plan to work with the Metacoin community on this?
Last month, I contacted Amin Soleimani. He started the initiative in February. I started working with Binance last year because I've been studying stablecoins. And then I bumped into Amin. I talked with him, and then he connected me with a former Maker team member who looked over my code. He was pretty impressed. And now they are helping me build up the community, and we plan to write a white paper in the next couple of weeks, and then start to get some funding.
Awesome.
Very interesting.
We will move on from there. Stefan, thank you very, very much for your presentation. We now move on to team Snappy Labs, who are a team of a PhD from UCL and a senior scientist at ETH Zurich. And I will let them present what they have built now. Over to you, Vasilis.
Hi, does this work?
Yes, perfectly.
Okay, great. I'm Vasilis, and this is Snappy, which enables fast payments for retail purchases. So if we consider payments in the context of retail purchases, there are several requirements that any payment system should basically fulfill. To begin with, we need the checkout process to be to be fast. So if you pay with Visa or MasterCard, it takes 3 or 4 seconds at most for the transaction to finalize. We need the system to be user-friendly for the average user. Again, think of the average user of Visa or MasterCard. We need it to be secure and reliable. So if we consider cryptocurrencies, in the context of retail purchases, and in particular permissionless cryptocurrencies, the reality is kind of different. So to begin with, you can't have fast checkout. So if we think of Ethereum, for example, it takes you approximately 1 or 2 minutes, maybe 3, before the transaction is considered final because of latency issues. So you don't have that. I wouldn't say that they're particularly user-friendly for the average person, and they are actually secure, but they are not perceived as secure, which is again another problem we need to work on. And finally, I wouldn't call them reliable just because, for example, you may have a congested network, for example, because of CryptoKitties, and now you're trying to pay your merchant, your supermarket, and even though you have money in your wallet, you can't. So to address all those problems and try to make cryptocurrencies accessible and available for retail purchases, we assembled a team between UCL and ETH Zurich, and we worked on that for a few months, the past few months. And we recently, in the end of February, we actually published our paper at NDSS 2020. And DSS 2020 is actually one of the top 4 security conferences. They follow a rigorous double-blind peer review process where you have experts unaffiliated with the authors going through the paper, trying to poke holes into the whole idea and the security proofs. So the paper was published there, and then we moved on into actually commercializing this and bringing this into production. So very, very briefly, how the protocol works. There are 3 steps. The first one is registration. So you as a customer who wants to purchase at supermarkets, you basically deposit the collateral on a smart contract. So this collateral is a small amount that you deposit there, and it's used only if you do something malicious, for example, if you double spend. And it needs to cover the amount of transactions you're going to do within 1 or 2 minutes. So if you don't spend more than £150 when you do grocery shopping, you should deposit, I don't know, £160, and that should be enough. Then you actually can go to merchants and start issuing payments towards them. The merchants will run the Snappy protocol on the background, and within 4 seconds, approximately, they will have a rejection or an approval. So here is an example of the merchant's interface. This is how it looks. On the top, you have the merchant's address where all the funds are directed to. This doesn't change for every payment. What changes is the value. For example, we put an example value there, and then you pay. Now the customer has to use their mobile wallet to just scan the QR code, and very quickly the payment will be approved. So of course, now this transaction is not yet on the blockchain, right? What happened is Snappy pre-approved that payment so that the merchant can go ahead and the customer can actually leave instead of waiting for 1, 2, 3 minutes there by the cashier. So what happens if the customer is malicious and the double spend? If the transaction doesn't end up on the blockchain, then the merchant can issue a settlement claim to the smart contract and get their money from the customer's collateral. And this is basically it. Thank you all very much. This is Snappy.
Perfect. So judges, any questions for Vasilis?
Thanks for the presentation. Just a quick question in terms of I think payments are really easy these days. In the UK, we can just tap and usually walk out. Have you any sort of incentives in mind to get people using this rather than using credit card or any sort of standard payment options?
Yeah, that's actually a good question. So I wouldn't say that a short-term goal shouldn't be replace Visa or replace MasterCard, but those systems are kind of priced depending on what the customer would pay. Like their customer is basically a supermarket, right? So this is not the cost that the merchants pay to Visa and MasterCard is not what it takes the cost of maintaining such a system. So that system is completely decentralized, and the fees that may emerge between the merchants essentially will emerge naturally, not because they have been priced in by Visa or MasterCard based on, how much would a large supermarket be willing to pay for our service. Don't know if I answered your question. Happy to elaborate further.
Awesome. One more quick question from the judges, if anyone has them.
I can ask one. Well, this is more like a point than a question. I don't think you should target merchants at all. I think on Ethereum, there's lots of services now where I have to put stake or collateral before I can do something. So you could actually reuse that collateral perhaps to do payments for like crypto services. So maybe I want a quick deposit onto an exchange. I have a CDP open. Why don't I just put that as the collateral and I just do my quick the exchange can quickly accept my deposit, knowing that if I don't give them money, they take my CDP or whatever else. That seems much more useful than merchant payments.
Yes,
we will allow a discussion to take place on privately in the interest of time. Thank you very much, Max, for this. We're now moving on to our final pitch before we go into both prizes and judging. And that is the wrong slide, but I don't know what's happened there. Let's make sure. I'm not sure quite what I shared there. So we will move on to team Deepverse, who have used Tezos and Arweave to build their project. So over to you guys.
Oh, hey. Hey, this is Deepverse. We work with Arweave and Tezos. So data privacy has been a big concern since the GDPR. But if we simply restrict access to the data, let me just move this. So, yeah, just a the problem. Yeah, but if we restrict access to the data, the value may be undermined. We're thinking of a possible way to utilize the information within the data and protect data privacy in the first place. It's a collective phenomenon emerged from the data that matters, not the individual data points. So we are the first to come up with a way to train predictive models using private database and store the models on the blockchain for others to validate and improve. The models are made public as a tip of the iceberg, which you can easily verify the accuracy, but you cannot see the actual data below, which is under the sea. There is a clear boundary between. The overall model will have a better performance and benefit everyone. So to illustrate how Deepverse actually works, we have three persons here, Alice, Bob, and Charlie, in finance or healthcare. Each has some private data and facing the same problem, say fraud detection or develop a cure for COVID. However, they did not wish to share the data, but would like to collaborate on tackle the problem together. So with Deepverse, Alice can now upload the neural network model to the blockchain. In this case, we are using Arweave, and Bob can continue on Alice's model and train with his own data and upload the updated model to the chain. Note, Alice cannot access others' database. Charlie can now evaluate the previous models and be more creative and make a powerful model which outperforms the previous one. We have developed smart contract here using Tezos, which reward contributions accordingly. So team-wise, we are three Cambridge PhD students study theoretical and computational physics. We deal with data and models all the time. We know people are desperate for such a collaborative platform with data protection to boost scientific discoveries. Now let me go to the web-based pilot which we have built. For more detailed explanation, we have provided a menu here. Suppose we have a machine learning problem such as image classification, self-driven cars, or find a cure for COVID. We can build different types of models and on the data and record the loss as a measure of the accuracy. Once we have trained the model, we can upload it to the blockchain. Here we have integrated Arweave into our website. You can check your balance after provide your key file, upload the file, or here is a model, and download the model with a specific hash. We have also integrated IPFS here as well. So now let's talk about the smart contract part of our project. A Tezos contract is provided here as default. So suppose we want to start a game, say name FOB, and with a threshold. The aim of a threshold is to drive the neural network's loss function below that, and that is considered as like a winning for them. We have also provided a mint tokens function and transfer them for a game as a reward. So afterwards, after you have trained the model, you can use the push to list with the updated loss function and the Arweave hash of the model, and store all that information on the blockchain. So once the winning criteria is met, the smart contract will automatically distribute the reward. I encourage everyone to try our platform and give feedbacks. So as Deepverse, we have the vision to facilitate greater collaborations with mutual benefits and make artificial intelligence working for us on solving real-world problems. So with that, I'd like to thank you, and we are now open for questions.
Awesome. Thank you very much, Fred. Questions from judges?
So just so I understand what you guys are building, so you're giving people incentives to share train models on your on your platform.
Yes.
And so and then so that's the supply side of the model. So what about the demand side? So who's going to use this and how?
For example, I can give you a scenario. Suppose like for pharmaceutical company, each have like a huge database on clinical trials, and they have already started on machine learning. But in this case, they would not like to share a sensitive model, say predictive for COVID. But in this case, they can come to a consortium and say like, maybe you take part of the vaccine, I take a part of the RNA, you take part of the DNA, and we can check which model, which treatment perform the best. And each of them has like a minimum level of trust. And with that, they can form together to congregate the data and try to push the development further without wasting everyone's effort to repeat the same thing.
Got it. Thank you.
Awesome. Any other questions from the judges? I think that wraps it up. Well, thank you very much, Fred.
Yes,
judges, you should all have now received both a link to a separate call for deliberation, and you should have the spreadsheet. So if not, Damir is going to be making sure you do. So if you could switch over to that call, judges, and we will do the overall prize giving for the competition. So judges, please switch over. You'll be deliberating. This time last year, we put Queen on while this bit happened. For those who were there, to a bit of a disaster. So yeah, judges, please switch over to Google Hangouts. And then we will get going with the prizes. Okay, good. So guys, now thank you very much, all finalists. Now we move on to, I said on Twitter and on our Slack, this is like Christmas. There are so many prizes to give away. So these are the prizes for the challenges in the competition. I should share my screen. These are the prizes for the challenges in the competition. We had many, many, many across our fantastic challenge partners. So I would like to, first of all, what's going to happen, we will hand over to each partner. They'll explain a little bit about the challenge, about who won the prizes. So very good. Moving on first to Jason Weatherby of Algorand.
Thank you, Anthony. Can I share my screen, or should I just read off the prize winners?
If you want to share your screen, feel free.
Okay. All right. All right, can you see my screen?
Yes.
Okay, these were our three challenge.
Jason, I think we might have lost you. Jason, I can't hear you.
Any code required. We also had a challenge for a MetaMask-like Chrome extension for handling creation wallets. And then finally, we have a smart contract language called Teal, and we had a challenge around using Teal or displaying Teal in unique ways and things that people did with it. So just, I'm not going to take much time. I want to thank Anthony and the Future Blockchain team for letting us be part of this, and really been a great experience. And some of the creativity we saw was fantastic. We originally had these three challenges. We decided to give away 5 prizes today. And the reason we did that is because we really liked some of the submissions that we got. So from the standpoint of winners, the decentralized Robinson list, we thought this was a unique solution. It used all of our key technologies, atomic transfers, assets, and Teal to implement the decentralized list. And we thought it was a really unique solution. And so they're awarded 25,000 algos. For a MetaMask-like Chrome extension, we had AlgoBox, which is a really nice wallet creation management tool, and it has support for future transactions, and it really includes a nice API. So they get 15,000 algos. For the Teal challenge, RAN Labs upgraded their Explorer to include anytime Teal's used in a transaction, that you can actually view it and also decompile the program, which was pretty cool. That's an award of 15,000 algos. For additional winners, there's the Inventors team. They developed a single platform for organizations to manage ticket sales and even including support for secondary markets. Really nice application. They are awarded 15,000 algos. And then Mango Dev is a team that built a generic asset creator for the blockchain. So it's a web-based GUI. go in and create assets in a matter of just a few clicks and no need to write any code. So it's really a really nice solution. They're awarded 15,000 algos. And that's our winners. And I will, just as a quick note, say we're also, Algorand just announced, we're supporting a program with 250 million algos for developer challenges, developer creations, and things like that. You can take a look at algorand.foundation to get more details.
Jason, thank you very much, and thank you for all your support as a gold partner in Future of Blockchain this year. Second of all, Tezos, our other gold partner, Bruno will be presenting the prizes for Tezos. So over to you, Bruno. Bruno, we can't hear you. You're muted.
Sorry. Thank you.
All good.
All right. So thanks, Anthony, and hello, everyone. So I'm a research engineer. I'm involved in the Tezos project. I'm very happy that I'm going to announce the rewards for the Tezos challenges. So there are actually 3 challenges. The first one were about building dApps on Tezos. The second one about building tools for Tezos. And the last one about making Tezos evolve. We are very happy about the many contributions we received, and it was very hard indeed to choose the winners. So without further ado, let me announce the winners of the prizes. So I would say it's a unified list for all the challenges. So the 5th prize goes to Tezmania with the 500 Tez reward. The 4th prize goes to Tezos ETL with a 1,000 Tez reward. For the 3rd prize, we actually have 4 ex aequo winners that will each receive a 2,000 Tez reward. So the 4 teams by alphabetical order are Deep Birth, QVote, that were finalists today, Tezos Care, and TZ Factor. Right, so for the 2nd prize, it will go to DRBNB, which will receive 4,000 Tez. DRBNB was also a finalist. And finally, the 1st prize goes to Chain of Insight with a reward of 8,000 Tez. Also, we have decided to give a smaller reward of 250 Tez to all the other teams that submitted a project. This is a sign of gratitude and encouragement to be part of the Tezos community. So again, a big thank you to all the participants and to the organizers of Future of Blockchain. And that's it for me. Thank you, Anthony.
Bruno, thank you very much and for your generous prizes and all your support with the competition. Just to let everyone know, I will be publishing a list of all the prize winners on our Medium after this, just so you can clarify if you got a prize and amounts and stuff. But feel free also to message me afterwards, guys, if you weren't sure if you got something or didn't quite hear. So now moving on to one of our silver partners, Graph, and I believe we have Martin to present their prizes.
Yep, thanks, Anthony. So we're giving 2 bounties. One was for building a subgraph to index your smart contracts, and the other one was utilizing an existing subgraph from Graph Explorer to build a front-end app. Our winners for building a subgraph are Unchained Games, Vision Pool, and CO2 Can. And for using a subgraph, it's Graph the Graph, Team DQ, Lent 721, and Unchained Games Vision Pool. Thanks to everyone that applied, and congratulations to the winners.
Thank you very much. Thank you, Martin. And once again, we will be publishing exact details on the Medium afterwards if you could have missed anything, missed amounts, etc. Next, we have Nir, and I see Peter. Peter's got, I think you ended up joining on my link because you've got my name, which is very disconcerting. So we have Peter from Nir, again, one of our silver partners this year. And I assure you it's called Peter and not Anthony Beaumont. So Peter, when you're ready, tell us your prize winners.
Hey there, yeah. Like Anthony said, my name's Peter DePaulo from Nir, core contributor running the DevX team. So our prizes, we had 2 sets of challenges. One was any number of people could use our single sign-on. They could get $100. Anyone who does this, anyone who actually stores data against the account ID that's generated gets an additional $500 and 100 tokens. And then we had a final prize. Our emphasis was on user experience and ease of use. And that would be $5,000 and 5,000 Nir tokens. So pretty substantial. So people who ended up using the account system were O10, that's OA10, Arlene Blackwell, a solo hacker, Decentradox. Then people who ended up storing data against the account IDs get an additional $500 and 100 Nir tokens. That's Nir Finance. And Chiron coin. And then finally, the person who received, or the team, I should say, that received the $5,000 and 5,000 NEAR tokens was Vivid IOV Labs. The engineers that judged found their user experience really good, and their technology really cool. So congratulations to everybody, and thanks for hacking on NEAR. Had fun on this this hackathon. Great work.
Thank you very much, Peter, again, for all your support and your great prizes. I am actually, the SAP unfortunately couldn't, we were running over time, as you've probably all seen. So I'm going to be reading the SAP prizes out. SAP were looking for a solution to kind of and use cases around enterprise, and participants could use any blockchain of their choice, which encouraged many of our participants to kind of both do another challenge and also enter SAP, which was great to see. And they have 3 winners. In 3rd place is Hyperaware, who were a finalist. In 2nd place, also finalists were QVote. And in 1st place were Prosperchain. So congratulations to those 3. In terms of the prizes, the prize was actually internships in SAP's Berlin office. And I'm assured that for all 3 winners, they will try and make good to that if they so want it, with geographical limitations applying. So we will be in touch about the logistics of that. But congratulations, and thank you to SAP for their support in the competition. Moving next on to Max from Zilliqa, who's going to tell us about their prize winners.
Thank you, Anthony. And good afternoon to everybody. I think we've seen and heard some fantastic pitches through this competition. And I'd really like to thank everyone that's participated and all the hard work that's gone into this. At Zilliqa, we had set 2 different challenges. One was for participants to try and introduce more complex behavior into something that we call social pay. And secondly, we wanted to use this social pay functionality for another social media platform. So then on to the winners. So we have 3 prizes. 3rd prize actually is £1,000, and this goes to Stream Harbor, which is a crypto donation service for streamers. 2nd prize goes to RedPay, which is a social payment platform for Zilliqa, and that's £2,000. And in 1st place, we actually have BaseBlock, whom we actually heard pitching their application earlier. £3,000 to BaseBlock. Well done to everybody. It was a tough choice. We're really looking forward to seeing these projects coming live on Zilliqa. So we'll be watching very, very closely. Well done all.
Max, thank you very, very much. And thank you for your support, not just this year, but Zilliqa were with us in the Future of Blockchain 1 as well. So here's the Future of Blockchain 3 also. So now moving on from our silver partners to our bronze partners. And the first is ADEX, and we have Vanina, the CMO, to reveal their prizes.
Hi, everyone. I don't know if you can hear me.
We can very well.
Okay, great. To those of you who are not familiar with ADEX, ADEX is a protocol and a platform based on Ethereum for decentralized advertising. The challenge that we issued was to come up with a solution to help us mitigate click fraud that works with the ADEX protocol. And the winner of that challenge is James Bacchini. I hope I'm pronouncing it right. Unfortunately, James failed to produce an actual prototype of the service, but he's submitted a proposal. So we decided to award him half of the prize anyway. So congrats to James Bacchini, and thank you everyone for participating.
Awesome. Vanina, thank you very much again for all your support with ADEX. So we are moving now on to Arweave. Victor, I believe you will be revealing the prize winners, and please do so now.
That's right. Hi, everyone. So first of all, thanks a lot, Anthony and Damer, for running the hackathon. Like we saw some really, really good submissions. So we actually had 2 second prizes originally of £250, but submissions were so good that we decided to actually give 4 second prizes. And so 2 of those are the finalists that you've already saw pictures of. That's Artistry and Differs. And also we decided to give second prizes to Swartz for allowing to store scientific publications forever on the permaweb, and also Puma for integrating Arweave into their privacy-oriented browser. And so first place, which is £3,000, we decided to give to the team that came up with, in our opinion, the most real-world solution to a real-world problem, solid code, open source, and yeah, really good solutions from our point of view. That's HyperAware. So yeah, first prize goes to HyperAware.
Awesome.
So yeah, that's it. Thanks a lot for all the submissions. Thanks for Hacking with Arweave. We're running Startup Boost program to partner with startups. And yeah, thanks again to the team of Stake Zero. That was a great hackathon.
Perfect. Victor, thank you very much again for all your support throughout the competition. Our final challenge partner who are revealing their prizes today are Catalyst. We have Joseph from the team who's going to present their prizes now.
Cheers, thanks. Can you hear me all right, Andy?
Perfectly.
Right, good stuff. So yeah, thanks again for organising the events. Well put together, and given the circumstances, I think this went quite smoothly as well. So just a big shout out to the organisers of this, and you know, and the participants as well. Obviously, wouldn't be anything without them. So for us, our challenge was to build a code extension for an idea of your choice to help with developing, packaging, testing smart contracts. So we decided to split the prize between two participants, James Piccini and Mac Karanjalkar. They both done a great job at simplifying the process, making it easy to spin up smart contracts within the platform. So very useful tool that they built, and both done a good job explaining what it is and how it works. So yeah, thanks for those that built it. I would just like to mention as well that for the Catalyst net, we've just made public our testnet. So feel free to check it out at catalystnet.org and let us know what you think about it. We'll probably have a book bounty campaign going later as well. So more to follow on that, but thanks.
Awesome. Well, thank you very much, Joseph, and thank you for your support as well. So I would like to say a massive thank you again to all the sponsors. It really goes without saying we couldn't do the competition without you guys, and not only your great challenges, but giving the students and all the participants the opportunity to work with them and work with you over what is a much longer period than a traditional hackathon. It's why we kind of design Future of Blockchain the way we do, is always to make sure we build that our participants go deeper into the space and to go deeper into blockchain technology, but B, that the final end product is better and represents a deeper understanding. So thank you all for your patience and your support throughout the many months the competition has run. So I've been told that the judges are still deliberating. So I want to say a few words just while the final result gets Slack messaged to me. So thank you all for taking part, all the participants. Those that were awarded by prizes, congratulations. Those who didn't, again, thank you for your hard work. To give everyone a kind of insight what goes on behind the scenes, we have been running this since kind of October on effectively a week-by-week basis, and some of these participants we've even seen from last year and October 2018. So we're delighted with the journey all of you have made, and we thank you for your time and effort, to the societies especially for helping us run the competition, the workshops, helping us keep contact with all the participants who've taken part. So thank you all very much for that. As I say, I will be publishing a list of prizes on the Medium, and I'll do a very quick one on Slack just in case anything got kind of lost in communication about the prize giving just now. I do have to now to waste a little bit of time because I'm still waiting for the results. But thank you all. It's been a good rise, and finalists, you won't have to wait too much longer. So for now, I'm going to be quiet for a few minutes, and we will await the final results. This, by the way, we've recorded this. This will go live this will go on to online, so you can kind of see the fantastic presentations in hindsight, and hopefully celebrate some good memories. It has been an interesting ride to do this online, very much compared to last year, which was an in-person event and very, very different to this. Thank you all, especially finalists, for your patience and hard work over the last few weeks. The last week or so, we have done a kind of daily basis kind of calls and pitch practices and everything to get these guys polished and ready to go. So excellent. Again, we will await the final result. I feel like almost it's like waiting for a Eurovision result. People calling in and then waiting for the deliberation. Very good. If anyone has any questions at all, please do put them in the chat. This has been ample time. I would normally put Queen music on at this point, but I'm not sure. I think the effect is slightly lost on on a Zoom call. Yeah.
Anthony, you should play the Jeopardy thing.
Yeah, play some sort of game at this point. So a question, maybe tell us what it takes to organize the event. Good question. That's good, because I can now talk for a few minutes. We always first partner with a load of student societies and clubs at all the universities we work with. This year it was Oxford, Cambridge, UCL, KCL, LSE, Imperial, and 2 in Berlin. As I say, we had inbound interest elsewhere, but the core of it ran at those universities. So we partnered and worked with them and got everything organized. We started with a launch event, which a number of the sponsor speakers were at in October, November, which was one in each city to kind of drum up interest. And then from there, once people have registered on a week-by-week basis, we kind of worked with you guys through online, on Slack, on the kind of workshops we organized, which we did roughly every 2 or 3 weeks throughout the competition in each city. And I've just had the result come in. And I've got the first, I've got the second. What is the third? Okay, good. Let me just converse with my colleague. So we'll just let the judges join back. And then we will do. I have the 3 in. They've just coming in hot. For prize winners, the judges are coming back in now. So we'll be announcing a top 3. One of the problems with this competition is it's structured as with general challenges and specific challenges. And for the general challenge, the only prize available is the top prize. It's always the case that when we announce this big top prize, that I'd love to be able to share other prizes with people, so that when I announce the top 3, second and third won't be getting anything via a metaphorical Mars bar. So we will give it about another minute, and then I will announce the top 3, and then everyone can go. To announce the top 3 in the competition. So again, thank you all for taking part. Without further ado, in 3rd place in the competition was Reflexer, Stefan's team. We will share some individual feedback later, but Reflexer, so congratulations for your hard work, Stefan.
Thank you.
And we really look forward to the project kind of going on leaps and bounds. We'll be following it very closely. In 2nd place, and I'm told it was a close second, were Artistry from Imperial. Dan and the team you've done a really fantastic job. I've really enjoyed working with you guys. I know that you guys want to continue with the project, and so you should. And we look forward to supporting that, but well done. The winner of the Future of Blockchain competition, the 2nd iteration, is Snappy Labs. So congratulations to Vasilis and the team. I don't see him on the video now, but congratulations. Damo perhaps could share some more information, but well done. You are the winner of the £10,000 top prize. Excellent work. I'm sure that will go towards furthering the project and bringing it a step closer to market. But excellently well done, and well done to everyone. And we will look forward to making sure you get all of your prizes. And yeah, so well done. Thank you all. The call ends here. I will happily kind of speak to anyone who wants to speak. Just PM me or message me on Slack, and I will actually stay on the call if anyone wants to arrange something separate to chat. But well done. Thank you all, and see you next year. Thanks, guys.